Welcome back to the channel, everybody. We are cutting right to the chase today. No intro because we're going to have a lot to go through. I'm going to do a starting engine disassembly for 1113. I figured because I have all these engines already disassembled here, you guys haven't seen how to take one of these apart, and I have this old nasty core that's got that 1/4 inch of crankshaft end play. I need to take this thing down and see if there's anything left of it anyway. Figured it'd be the perfect candidate just to do a kind of a demonstration disassembly. I've got some props kind of laid up here on top of it just to kind of give you an idea what all has to come off. The only thing I didn't have at hand today was that little downdraft Zenith carburetor goes right here. You can see it in place on this one over here, right there. So not a big deal for the most part. We've got a complete starting engine to tear down today. And Senior already has a 5-part video series on completely rebuilding these little Zenith downdrafts for these Caterpillar starting engines, and they fit the John Deere tractor starting engines as well. I'll throw those up when we get to the proper time in the sequence. But in the meantime, let's tear into this thing. I'm pretty sure I know why we have that excessive end play. Usually it's this back main bearing back here. Technically it's the front main bearing, but pretty sure that thing lost its dowel pin, loosened up in the block, and that's why we got that crank floating around. But let's get into it. So to begin, quick backstory on this twin-cylinder opposed style starting engine right here. This was used for a lot of years on a lot of different models of cats, D2s and D4s, mainly from 1930s. I think beginning in 1934 when they came out with the D4400 and the D4 I should say, on up through the late 50s. So a lot of different cats used this style starting engine, mainly the short block assembly. Highly modular, highly interchangeable. All the bolt-on pieces are what changed, but the short block with rotating assembly that you see right here began, like I said, around 1934 in the 4G series RD4, and then other D4 models that use this would have been 2T, 5T, 7J, 6U, 7U series D4, all use this same short block with rotating assembly. And in the D2s, the early 3Js and 5Js, and then the later 4Us and 5Us, all used this same short block with rotating assembly. What really changed was the periphery items, the bolt-on components. Like I said, highly modular. They just used the same basic short block, and as design upgrades came about, options were released, it was all just bolt-on stuff. They started out as a rope start. You can see this is where the knot of your rope would go, that notch or that notch there. You would wrap it around there. It gives you a direction in which it turns. You'd give it a pull and then it would start. But then they came out with electric start versions, which we'll go over here to this one. You can see this one has electric start, but it's all bolt-on stuff. It's just, like I said, highly modular. This whole electric start drive system can be taken off of this and it can be put back to a rope start. The other main difference, rope start to electric start, is in the crankshaft pulley. You can see this rope start only has the one belt groove back here for the governor, but an electric start has 2 belt grooves. There's your governor belt groove there, but then another V-belt groove is milled in here. That's for that electric starter drive that you can see on this one. So electric start uses 2 belts, rope start only uses 1. So with that out of the way, we can begin the disassembly. I like to pull this crank pulley off first because it's really heavy, and I get this off the front. It balances this little engine a lot better. There is a fold over lock behind the large pulley nut, so both of those would have to be undone, and this is on a tapered shaft, and you're going to need a puller to pop it off. Now, do not use a jaw type puller on this rope flange because you will break the flange. It is that tight, guaranteed. Those do not work well, but you have threaded holes here and here where you can put in bolts and use a bar style puller. Forcing screw can go on the end of the crank pressure down. But another thing you do not want to do is hit the end of the forcing screw to try and pop that off, because this is a hollow journal crankshaft and this rather thin center web. Those crankshafts do not like shock loads coming straight in on them, but it is permissible to take a hammer and tap radially around that flywheel, get it to pop off. I still like to try to brace them in some way, but that's the best way to do it. A good quality puller with good bolts is your best bet. So once that pops loose off the taper, it could just be taken off. There is a key way you have to take off. I see this one, I just had it loosely assembled, so this one went with the pulley, or with the flywheel, I should say. And again, that's that crank in play that we're going to have to get to the bottom of. Now to begin taking some of the things off the top, carburetor's not in place, but you guys can use your imagination as far as that goes. These are early D3400 style components up here, so depending on the engine, the model, the year, your equipment package, whether you have electric start or not, all this stuff may look different, slightly different, but the general idea is the same with everything. So we'll just take the mag switch and the throttle and choke rod assembly off. This is an early D3400 style breather. That will come right off. Next we have this early style exhaust pipe. Now, like 1113 here, these early D2s, they did not utilize any of the heat coming out of the starting engine. That has not been cut off. That's how this one came from the factory on these early build ones. So many different types of exhaust. Shortly after 1113 was built, well, 2-3 years probably, they started piping that starting engine exhaust into the intake manifold for the diesel engine. They had a heating jacket in there to utilize that heat for starting, but this early first gen stuff, exhaust pipe can come off. Governor can come off next. You can see the mounting holes are slotted. That is for tensioning the drive belt for that. And of course we have old nasty spark plug wires on this thing. Pretty much standard when you get into these old starting engines like this. They had put some insulators beneath the routing clips, but it's all pretty well deteriorated now. Peel these out of here. They're going to go right into the trash can. The Magneto can come off now, so bear with me while I get this turned around. There we go. There are timing marks for the Magneto. They can be accessed beneath this pipe plug right here. This is going to be real fun, making a GoPro focus down into this little hole down here. But you can see there's an M mark right in the light there on the mag gear, and a corresponding M mark on the cam gear. You want to have both of those lined up to be in time. That is how you access those. And then just 2 flange nuts on the Magneto, and it can just pull straight out. There you can see the gear, and there is that M mark we were looking for down at the bottom. Alright, now something else to cover here quickly. I have some more props for you guys to look at, but I thought this starting engine was an excellent candidate to do a disassembly procedure on because of, like I said, this excessive crankshaft end play, and there's also some profound radial play on there. Very loose crankshaft on this one, and this causes a problem with these Magnetos. You can see I mentioned the drive gear right here. We'll just take a look at this one. It's got some missing teeth, as you can no doubt tell, and that is caused by these crankshafts starting to run loose, not only floating in and out, but also, you know, up and down. When the crankshaft gets really loose on these engines, it causes all kinds of erratic changes and backlash that go up from the crank gear into the cam gear into the Magneto drive gear. Also, different shock loads, vibrations happen, and the weakest point of the system is the Magneto and gear. And what happens is you can it basically starts shearing teeth off of that mag gear, and it also bends or breaks the armature shaft inside the Magneto. You can see this one, it twisted it clean off. So unclear as to whether or not these things start losing teeth first, or if they bend that armature shaft first, which then starts wedging teeth and then it sheds them. Either way, very bad things can happen when these starting engines are allowed to run this loose. So just another instance where they're either right or they're not. If you have a loose crank, you have to correct it. All right, next I can remove the top cover, and this is the last component on the starting engine here that has a lot of differences in it depending on which type of machine you have. So this is the D3400 and D4400 style. Of course, the 3400 was in the D2, the D4400 was in the D4. They both used a similar style top cover that had the coolant outlet right at the top here that fed into this passage on the back of the diesel cylinder head. Now, in roughly 1947, when the D3400 went away and the D4400 went away, they were replaced with the D311 and the D2 and the D315 and the D4. They also changed the top cover of the starting engine. This is what I call a U series, which would be D311 or D315 starting engine top cover, and you can see they got rid of that coolant outlet right there and went to this elbow that just feeds a hole in the side of the diesel engine cylinder head. So a little bit more reliable piece, even though there's more potential leak points. It didn't rely on a pressure pinched seal like these early style units did up here. Now, of the early D3400 and 4400 starting engine top covers, there is yet another difference to keep track of in this water outlet area. We'll look at this one first. This is a early first gen, as I call it, top cover. You can see we have a milled in slot that goes all the way around that water outlet, and it would take a soft rubber seal like this that has a corresponding raised lip that goes and engages with that slot, and to replace the seal you would have to loosen the starting engine, cant it away from the diesel cylinder head, change the seal out, and then tighten it back down, and that would apply the tension to the seal to keep it all watertight. But later style, they basically did away with that milled in groove, and they just milled a flat around that used a different style seal that has, you can see it's got a metallic kind of frame to it, and it has vulcanized rubber on each side. And what this allowed you to do was to basically replace this seal without having to loosen the starting engine and cant it back away from the diesel. That way you didn't have to fool with your base gasket potentially leaking and all those other good things. They even had an article about it in the Selected Service Articles book where they talk about the new manifold water seal. You can see it is this style right here, and they even give you dimensions for basically milling out that area on these old top covers to do away with that recessed groove and make them conducive to using this newer style seal. But anyway, to get back on track here, bolts out so the top cover can come off. Peel the gasket off next. Front cover comes off next, and the bore for the idler gear shaft is kind of also an alignment dowel, kind of a very large alignment dowel for this thing. This one looks pretty good. Usually this area right here has been broken on these because when you're taking this off the diesel engine, that's kind of a hidden bolt back there, and sometimes some grease can just kind of hide it. So a lot of times people still have that bolt in, they give it a pry and cracks that whole bottom ear off, but this one's looking pretty good. Oh, there we go. Take the idler gear off now. This is why I've had it sitting on this little 2x4 frame, is because this sticks down so far. So, working on taking what's left of the oil drain tube off right now. Someone's actually broken this one off, which is pretty common. They've plugged the end of it with some clear silicone, and they actually flipped it upside down. This broken off end is supposed to be sticking out that way. I've seen a lot of these broken, but I've never quite seen one done up like this. I don't think there's no oil down in there. Yeah, they got silicone packed all through this thing. So just set this, actually flip it around. This is what they're supposed to look like. This is the aluminum style. You can see that's the end right up here, and then the whole rest of the tube has been broken off of it. They also had a cast style, about the same, and then there was this style, which is a bit newer than both of those, kind of a replacing piece. But pretty common to see these break because when they're positioned correctly, like that, they stick down. They're the lowest point, and if you don't have it on some sort of block like I do, it's going to hit this end first, and the weight of the engine's enough to crack that end off. Or if you've taken the side panels off of the diesel engine, the tracks will kick up things and it'll snag the end of that tube and break it off. Anyway, pretty common to see. Cylinder heads come off next. Work this off. The studs, a lot of rust in there. And you can see water jackets full of chunky rust. Again, to be expected with these. There we go. Oh, there's been a little bit of water in this one. Looks like, yeah, the valve stuck open a little bit here. I think it's, there, closed. So valves, guides, and springs come out next, and they're kind of a unit that's held in by this little, it's like a circlip right there. Once I get the valve and the guide and the spring and everything out, then the lifter that's behind it can come out. So the best way I've found to get these little circlips off is to get down in here with a screwdriver, find the end of the valve guide, and then you can see I'm prying it back. That takes the tension off that circlip, and that's how I can get that out of there and then remove that entire little assembly. Okay, there's the clip that holds it all in. Sometimes you have to help those things out a little bit. There we go. It just takes a little bit of carbon to stick those in. That's your entire unit right there. Guide, spring, keepers, valves. I can drift that lifter out. There's that. Wow, these valves are sharp. Not a lot left of them. I think they've been worn and then ground down a couple times already. And with all the valves and lifters out, the camshaft can be pulled right out of the block. Notice the timing marks. We have a C on the cam and a C on the crank gear. That is how you properly time those. Line that back journal with the bore and just slides right out. Now that we've got enough stuff out of the way where we can actually have a look at things, I just want to see, wow, look at how loose that crankshaft is. That thing really moves around. And it's like I thought, when you look down in there, down here, you can see that back crank bearing floating around. It has spun. Check some. Oh yeah, we got some excessive rod bearing clearance too. Look at how the crankshaft moves, but the rod doesn't. It just clicks inside there. Not awesome. So the next step in the process, after learning your crankshaft is floating all over the place and the rods are ready to fly off, is to get the gear pulled. So 2 bolts, a fold over lock, and this flat plate are what retain the gear onto the shaft. The gear is also a press fit on the shaft. There are 2 keyways to locate it, along with a C mark stamped in the end of the crank that must be in line with the C mark that's stamped into the gear. 1/4 by 20 thread pitch holes there and there for putting bolts in to help you remove that gear with a puller, and I'll also use a steel blank to go on the end of the crank for the forcing screw to bear down on instead of the live center hole that's drilled in the end of the crank. Because it's so close to those threaded holes on each side for the retainer plate, you don't want to mushroom that out and displace metal into those holes, wreck those threads. Give yourself all kinds of problems. There we are. There's the gear. My plug that protected the crank. There's one of the woodruff keys. Go under the gear. Let's see. Yep, I can peel the other one right out by hand too. And as long as we're right here, so we can loosen it up. Yep. We've got the sleeve for the lip seal. There we go. Let's have a look at that. Actually, this one looks pretty good. I've seen some of those get pretty darn rough. So that makes me happy. Found a good sleeve. That's not really easy to do. And this is the lip seal right here. We'll just leave that in the block for now. Yeah, look at that's our main bearing. Ugh, shot. Working on the other side of the engine now, getting this rear cover off. That's going to open up the crankcase quite a bit for accessing the rods. Yeah, that bearing's kind of scored up. Locating dowel is still in place though. Okay, so all we have to do now is unbolt the rod caps, and the piston and rod assemblies will come out each end, and then the crankshaft can be withdrawn out the back here. I'm already seeing things like no cotter pins on any of the castle nuts on either rod cap. That really instills confidence in the last person that was in here working. But these can be kind of fun to access. That's why we take this rear cover off. Sometimes you can get a ratchet or a wrench in here to work on them. Other times it takes 2 or 3 different size and length sockets to work down from the top and get at the top, or the upper ones are not too bad. It's those lower ones that kind of down here that kind of pose the problem. But a little bit of patience, you can do it. Okay, there's one of them. Not sure if we can call that a victory or not. Definitely been some water in there. Wear on the rings too. Wrist pin doesn't feel too bad. Still has a rod bearing in the other end too. Same goes for the cap. I guess they don't look horrible. They're kind of dirty yet. One down, one to go. There's the difficult one. Rod cap, bearing still there. All right, this one does look better. A little bit of moisture down at the bottom. No real click in the wrist pin. So, check out the bearing. Honestly, the bearing in the rod doesn't look bad either. I've seen a lot worse. Funny they were so loose on the crank like that. And finally, we can just pull the crankshaft right out. Have a look at things real quick here. Lots of grooves where that front main bearing spun. That journal is worn. Rod journals don't look horrible. Of course, I'm gonna have to mic those. Rear main doesn't look horrible. I'll mic it all and see where we're at. Looks like something was in the process of building a nest in here. And I'm just kind of probing around, seeing if I can find the alignment dowel that should be, or sorry, retention dowel that should be right here for that front main. It's not even here, but this should be a press fit besides, and you can just drift it right out. So, wow, that's got some wear. That's where that dowel should be. Hole looks a little oblong, so maybe that thing came out when they drained the oil, when they broke the oil tube or the oil drain tube off. But yep, that's shot, and that's usually why you get excessive crank in play. That little locating dowel comes out, and then these things start to spin, and then all kinds of bad things happen. So that does it. That's complete teardown on a starting engine. I told you guys these are pretty basic, not a lot to them. Just a quick inspection with calipers to see where I was at with this crank. I don't think it's ever been turned below standard. It's got some wear on it. Both of the main journals are worn about 10 thousandths below what standard size would be right now. I think a 20 under grind would clean those up. And the rod journals really surprised me. From 1 to 4 thousandths worn, about 4 thousandths out around on each. A 10 under or a 20 under grind would clean those up as well. So I think we got a good crankshaft out of this. The pistons are 20 thousandths oversized, and honestly, they don't look like they're that worn. No excessive side clearance on the rings. I'm going to get these things apart, do a thorough cleaning and inspection, but if I find that the wrist pins are a good fit in the pistons yet, we may have also gleaned a set of 20 thousandths oversized pistons out of this for something else as well. The bores are right on 20 thousandths over, not a lot of wear, but this side that had the water in it has some pitting that is not going to hone out, so we're going to have to do something with that. And we're also really going to have to scrutinize this main bearing bore here where that bearing spun so bad. I'm not sure that's the size that it once was anymore either. But remember guys, this is our parts store now. This is what we have to do to get a lot of the components we need to make other engines work and run. This is how we get our spares. With a little bit of rehab, I'm pretty sure we got a good crank out of that junky engine. I don't know if the block's going to be much good yet, but maybe even a decent set of pistons and a few nuts and bolts. Like I say, this is our store. This is what we have to do for our spares. So, well, kind of a long video, I know, but it's going to take me several days here just going through all these parts and pieces that I have to try and put together which block I want to use, which cranks, which rods, which pistons, which everything, and to see if I need any other machine shop work to get other good units put together. So it's going to be probably a while before I come at you with another installment for the starting engine here, just because of the legwork I have ahead of me. But as always guys, thanks for watching. I'm going to get cracking here. Hope to see you back again.